Okay, everyone, so let's continue. So the other important command is called pretest. Okay, so in the pretest, you want to test whether a certain variable is equal to a specific number. Okay, so for example, I want to test whether the variable called female is equal to an average of 0.4. In other words, you want to test whether the mean of the variable female is 0.4. You can think of it as whether the variable or whether I have 40% of my data set females. Okay, or probably you want to test whether 55% of your data set are females. Okay, so you want to test whether the proportion of females is different from 40 for this one, or 55, not 54. This is 55. Okay, so to do that, so you basically you do a pretest command female equal 0.4, and in a question I would be asking you for a specific variable and a specific mean. So what you get is the following. So you get the command and you get one sample test proportion, and this one sample test proportion is telling me I have number of observations 3,796. The mean of the variable is 0.54. This is the actual mean, okay? But I'm testing whether this mean is equal to 0.4, okay? So you have three options here. So this is your null hypothesis. The null hypothesis is saying that the average of my sample is 0.4, okay? The alternative hypothesis, you have actually three alternatives. Whether it's 0.4 but not equal to 0.4, the exclamation mark and equal is not equal, okay? So whether the mean is not equal to 0.4, whether the mean is lower than 0.4, and whether the mean is higher than 0.4. So remember, every time you're performing a statistical test, you have only one null, but you can have different alternative hypotheses, right? So if I'm asking you whether the variable female is equal, then the alternative would be unequal, right? So you would go here and say the p-value of the test, right, that female variable is equal to 0.4 has 0% probability. In other words, there is a 0% probability that p is equal to 0.4. And if the probability is low, see, it's a 0. So if the probability is low or 0, so you basically say that we are going to reject the null hypothesis that female is equal to 0.4 and accept the alternative that it's not equal to 0.4. Okay. You can also look here, right, and say that where is it? 0.4. I'm writing here in green here to make your life easy. So the p-value of 0.4 is only 0%. Thus, we reject the null hypothesis and conclude that the mean of female is different, so it's not equal to 0.4. How about if we test that it's equal to 0.55, which is close to the actual number, right? So you check the p-value. The null hypothesis is 0.55, and the p-value of the test is 0.56. So there is a 0.56 probability, in other words, 56% probability, okay, that the 56% probability that it is equal to 0.55, right? So in other words, you fail to reject the null. Like the 56% is actually a high number. So when you go here, the p-value of 0.55, the p-value of the 0.55 test is, this is actually, okay, is 56 point, sorry, it's 56, right? You multiply this number times 100. It's 56.14%, okay, which is higher than all significance levels. So you have 1%, 5% significance level, 10%. So the 56 is higher than all conventional significance levels. So it's very high. So there is, you can say that there is a high probability that the mean is equal to 0.55. Okay. Thus, we fail to reject the null hypothesis and conclude that the mean of female is equal to 0.55. Okay. So you can repeat this with any other variable, actually. So here I'm doing it on female, or you can actually do it with any other variable. Okay. So how about if I'm doing two variables? Okay. So this is called the pretest with another variable. So two variables together. Okay. So to test whether the proportion of females is lower among individuals with high income group. Let me put this in one sentence so it won't confuse you. Okay, with high income group. To test that, I have females, and I also need to have the variable for income high. So when we go here, income high, it takes one for families with income greater than 25K and 0 for families with less or equal to 25K. Okay, so you can think that those from income high takes 1, then the income is high. So in order to test that, so we basically write pretest female by income high. And we test it and we see it the following. So basically we're focusing on females only, right? So we're taking only females and we're trying to see how many of the females are in the low income group. So I have about 56% of females in the low income group, but I have about 51% of females in the high income group, and the difference between these two is right here, and we're testing the difference, the proportion of being 0, or the proportion of those who come from the low income group minus the proportion who come from the high income group. So in other words, I'm testing for this one, and I want to see my null hypothesis, whether this difference is not significant, whether this difference is close to 0, right? There is no significant difference between the income group of the high and the income group of the low. And again, remember, everyone here is female. So the difference is 0. So this is what we're testing. We're performing the test on the 0, whether it's not equal to 0, whether it's greater than 0, meaning that the income of females who come from the low income group is statistically significantly different from the females who come from the high income group. And this is the opposite, right? Whether the proportion of those who come from the low income group is statistically significantly lower than the females who come, or the income of females who come from the high income group, right? So this is what I'm seeing here, and I'm summarizing it. The proportion of females with low income status is 0.56, right? The proportion of females with high income group is about 0.51. Using the alternative hypothesis, let's say if I'm using the 0 or the greater one, let's say this one, I want to test whether the mean of females in the low income group is higher than the mean of females in the high income group. Okay, and what we can find is the probability is 0.013, or you can multiply this times 100, right, and say 13%. Again, 13% is very low. What do I mean very low? Well, I compare it actually with the significance levels, right? So you can actually repeat the same sentence and be specific. It's very low. Okay, it's very low when compared with all significance levels that we have: 1%, 5%, and 10%. If I have a low probability that this is true, right? There is a low probability that this is true, right? So what we say is we basically reject the null hypothesis. I reject this one and I accept the alternative. I accept that the difference is positive, right? In other words, I accept the alternative that the proportion of females in the low income group is statistically significantly greater than the proportion of females in the high income group, right? Because this one represents the 0 for the low income group. This one represents the 1 for the high income group, right? And right, and okay, and this is will be conclusion, reject the null hypothesis, right? And of females in the low income group is statistically significantly higher than the proportion in the high income group, right? So this is like a complete conclusion. Okay, this is exactly what you see in your practice and your assignment. So basically you need to study the two-way table, like the command right here, the one-way table, right, table of statistics, a pretest command, okay, with a constant, right, I'm just having one number here, or a pretest command with another variable. So I do have two variables, I have female and I have income high. Okay, so once you study these, you can just open the practice and repeat with another data set.